My name is Tiffany Slater, and I am American. I'm from Kentucky, but I am a paleobiologist, and I do most of my research in Cork in Ireland. I think a simple answer is that we can look at the natural world around us and see that there is plenty of color. And we see that it's very important to have color. So when we're signaling to other members of our species that we're available for mating, or maybe we're signaling to predators that we're toxic and you shouldn't eat us. So that is a very simple answer. But another way that we can tell that the fossil record have so much color is because these pigments preserve in the fossil record. So we actually have physical and chemical evidence that these pigments were existing in ancient animals like dinosaurs and even feathered dinosaurs. These black and brown pigments are the ones that are most easy to detect in the fossil record. And this is probably twofold. So it's because black and brown pigments are absolutely everywhere. So not only in today's animals we see black and brown. I mean, my hair, we've got, brown is the most common hair color that you can find. So it's a very common color in the animal kingdom. So therefore, it's reasonable to conclude that it's pretty common in the fossil record as well. Now, the other reason that black and brown pigments are so much easier to detect than others in the fossil record is because they are so robust. And by this, I mean that they're much more likely to survive the process of fossilization than any other pigments that exist. There is something to their structure and their chemistry that makes them so strong and able to withstand everything that fossilization puts them through. When we're talking about fossilization and everything that a fossil goes through before we find it and dig it up out of the ground, it's a very complicated process. So when we start analyzing fossils, we need to take this into consideration. So this new way that myself and the team of researchers I was working with, this new way that we analyzed and were able to detect these ginger pigments is by doing experiments in the lab. And so we took feathers and we matured them in ovens, and we did different things that they would likely go through during fossilization, and then we studied those. So this is really nice because it gives us a proxy, and we can analyze what's remaining in these modern feathers that we've artificially fossilized, and then we can compare that data to our fossils. And this indeed affirmed that we were able to find these ginger pigments in the fossil record. I certainly hope so. It's definitely a conundrum. So when we talk about brown and black pigments, those pigments really protect our cells. So when we are getting irradiated with the sun, we oftentimes we might find that where our freckles are showing a little bit more, and this is because our body is producing these black and brown pigments to protect our cells from damage from the sun. But the thing is with these ginger pigments, they don't protect us from the sun. So actually, they do the opposite. When these ginger pigments are irradiated with the sun, it can actually damage our cells. So it is very confusing as to why they evolved in the first place. And we're really hoping that this research will start paving the way towards detecting these ginger pigments much earlier in the fossil record, and also analyzing their very basic chemistry millions and millions of years ago so that maybe we could piece together why and how they evolved. Great question. So I was very interested in evolution, modern day evolution. We look around and it's happening all the time. So we see things like birds evolving at a really rapid pace, with Darwin's finches and the beaks evolving to be able to feed on different food. And honestly, I got carried away a little bit. So I started studying evolution much deeper and deeper in time, and got very interested in macroevolution, so evolution on a very, very long time scales. So I just kept asking and answering questions, and lo and behold, I found myself as a paleontologist. So it's definitely not a route that I planned by any means. I think it was just out of a lot of curiosity about the natural world and how things change over time.